Hi, my name is Emily Weber. I'm a machine learning specialist solutions architect at Amazon Web Services, and today we're going to learn about automatic model tuning. So let's get started. So today, again, we're going to cover automatic model tuning on Amazon SageMaker. And I should say that this session is really for data scientists. This session is for individuals who really enjoy building, training, and deploying machine learning models. And so we'll keep that in mind. This session is really for people who are already familiar with machine learning basics. If you prefer reading through some of the content visually, if you want to look at some of the equations, look at some of the code snippets, and read through some of the guided steps, then you can follow the companion blog post on Towards Data Science. You'll find this on my Medium handle. So we have the article published on Towards Data Science as a companion for this session. So feel free to read through there. And so today we're going to come to understand that, as you're familiar, there are indeed many ways to evaluate machine learning models. Accuracy is one of them, and it's something that our stakeholders can really relate to, can really develop confidence in. But that doesn't mean that accuracy is always the best type of metric for a machine learning solution. And so we'll unpack some of the different ways to evaluate machine learning models. Once we've landed on the evaluation metric that we prefer, we'll learn about what's called a training job as a construct on AWS. And a training job is a way within Amazon SageMaker we can bring our own models, whether those are packaged up in Docker or defined in Python or even using a built-in algorithm, and essentially turn on a dedicated instance. So that's a dedicated EC2 instance or cluster of instances that is going to run based on our commands. So we can configure this, set it up, bring in our images, bring in our own, custom Python packages, any Linux packages that you need, get that wrapped up, and then walk away. And so we'll learn about the training job as a construct. Once we've identified how to train a model on Amazon SageMaker on the AWS cloud, we're going to learn about a 4-step process to tune our own models. So how to take our own machine learning models, again, be those TensorFlow, Scikit-learn, XGBoost, MXNet, PyTorch models, and tune those using SageMaker automatic model tuning. And then we'll look at some retrain and tune pipelines. So once you have a model packaged up, tuned, ready to go, and you have this deployed on a SageMaker real-time endpoints, we will also learn about building a retraining pipeline. So you can trigger some event that will retrain and ideally retune your model, right? So rather than just getting the baseline, you can actually get the best performance model possible for your use case. We'll also talk through some edge cases. So we'll look at ensemble models, text, model tuning, visioning, and transfer learning. So we'll talk through some examples there. And so right off the bat, there are indeed many ways to evaluate machine learning models. So again, as we're familiar in the data science community, or if you're new, if you're just getting into data science, you'll learn that there are a variety of statistics that we care about, a variety of methods that we can use to evaluate and triage the performance of our machine learning models. And accuracy, which is that term all the way on the left-hand side, accuracy is really useful when you have a balanced data set. So when you have pretty nearly equal cases of what we call the positive class, which is usually what you're trying to find in your model and in your data set, and then in the negative class, which is an instance where you did not find whatever it is we're looking for. So when we break down the predictions from our model, both in the positive and the negative category, and then compare those with the ground truth, the risk of using accuracy as a performance metric is that it can be heavily weighted on either true positives or true negatives. So in the case of financial detection fraud, where we're dealing with potentially billions of financial transactions per day, the normal case, actually what typically happens is that less than 1% of those transactions are fraudulent. The tiny number of the transactions that are fraudulent, whereas the overwhelming majority are normal, are non-fraudulent. So if we take a data set like that, and if we train a model on that, what do you think is going to happen? We're going to get pretty good accuracy right off the bat. And that's because that class balance is so huge, right? We're overwhelmingly indexing on the normal cases. And so that's a problem when we use accuracy as a metric in that use case, because we might catch zero fraud, right? Our model may be catching 0 cases of fraudulent transactions, but we still have a 99% accurate model. And so again, be cautious when using accuracy. Another term you'll see commonly when we're evaluating machine learning models is called error. Error is nice and simple. Error is literally the difference between y bar, which you see right there, that y with that little line on top, y bar, which is the prediction that's coming out of our model, and that natural y, or that plain y, and that's the ground truth. So if you think about it, again, we're predicting financial detection fraud or financial transaction fraud. That y, that would be the label. So on the actual data set, the label for whether or not that transaction was fraudulent, but then y bar is the prediction that's coming out of our model. So error is just the difference between those two, right? It's just literally subtracting one from the other. And so error is a common base metric for regression in particular. But usually it's common to not just use error. We'll use error as a base metric to then compute a variety of statistics on top of that. So something like mean, average, percent error, if we want to know, how well our regressor is performing over a larger data set, or root mean squared error, RMSE, very common mean squared error. So there are a lot of, again, statistics that we can use on top of that base error. Precision and recall are 2 additional ways that we can understand how well our model is performing. And they vary. So in the case of precision, we're going to index on precision when evaluating our ML model, when the thing we care the most about is that we need a reliable positive signal. So when our model is telling us that this transaction really is fraudulent, we need that to be incredibly reliable. That's when we're going to use precision as an evaluation metric. And then conversely, we'll use recall when we're most afraid, say, of missing positive samples. So if we're really afraid of not catching a case of fraud, then we'll index on recall. And the metrics you see here, they're not super precise, right? They're sort of conveying a concept rather than necessarily being the exact definition, although they're pretty close. And then the last metric you see over here is loss. And so loss, of course, is a statistic that we use in deep learning in order to perform the backpropagation algorithm, right? To backpropagate the loss, which we need to descend, through the gradients there to then update the parameters in our neural network. So loss is literally some function of error, actually. So we'll take that error, which is, again, the difference between the prediction from our model and that ground truth. We'll take that error term, and then we'll drop that into a differentiable function. Then again, the reason we need to do, take the derivative of that is so that we can update the gradients and perform our deep learning process. So all I'm trying to say here is that there are many ways to evaluate machine learning models. And as we're developing as data scientists, it's helpful for us to become discriminating about those and really learn the best ways to evaluate our models. And so let's say that we've picked a model and a model evaluation metric. And so we've determined the best way that we want to solve this. How do we train this model on SageMaker? So you have 3 primary ways of training your machine learning model on SageMaker. And we're going to look at these. So the diagram you see right here is what SageMaker, the service, is going to manage for you. And again, SageMaker, fully managed service that's built and developed by Amazon that we can use. SageMaker is in every AWS account, right? You can open up the free tier, open up the console, and just get into SageMaker. It's in every AWS environment. And so couple ways that we can use SageMaker to train our models. One common way of using SageMaker to train a model is from what's called SageMaker Studio. And so SageMaker Studio, there are sessions about that here at the ML Summit, so feel free to dive into those to learn about Studio. Really rich dynamic UI that we can use. We can also use notebook instances. We can also use our local laptop. So a lot of ways that we can develop. In any case, we need to define this model. And again, this model is going to be, number one, a Python script that's using a framework that's fully supported. So scikit-learn, XGBoost, TensorFlow, MXNet, PyTorch, Chainer, Apache Spark, SparkML, so lots of containers. And so that path is called script mode. We'll look at a couple examples for training a script mode model. But in any case, you define your Python script, drop that inside of our managed container, and then call model.fit. When you call model.fit, a couple things will happen. First, we need to make sure your data is in an S3 bucket, right? We need to actually upload that CSV file to your S3 bucket. You can do that through the browser. You can just click upload, just do that straight through the console, or you can port that in from your corporate data center, right? You can set up Direct Connect. You can set up all sorts of really nice ways to hydrate what we call your data lake. So in any case, you need your data sitting in an S3 bucket by and large. SageMaker will turn on one or a number of EC2 instances that is dedicated for your model. That means no one else is going to use those instances. If something breaks, you're not going to shut down everybody else's instances. That is elastic compute that's going to turn on exactly for the purpose of training your model. That's why it's really nice to train machine learning models on the cloud, is because of that elasticity, right? The compute just naturally turns on when we need it. And so we get that elasticity with SageMaker. So we're turning on a SageMaker training job, which can again be one or a number of EC2 instances. We can have tens of instances in our clusters on SageMaker. And so we can get really advanced compute. We can get, P3s, P4s. We can get compute optimized, so the C family of instances. We can get something much smaller when we're just prototyping. So you have a lot of variety in terms of the compute that you can use to train your model. And then the actual model itself is going to come in from ECR, so the Elastic Container Registry. ECR is a way that you can build containers, so build a Docker image with whatever software it is that you want to use, be that from H2O, DataRobot, Databricks, really any Docker image. Build that Docker image and then push that to ECR. So you'll push that image to ECR, and then you're just going to point to that image when you're training your model on SageMaker, right? So we'll call model.fit, and this instance is going to come online. And so that instance is going to train, right? We're going to execute your training script. We'll process that for you, fully managed cluster. And then when that job completes, the cluster comes down. So all of the compute is dynamically turned off. And then we're going to drop your model back in your S3 bucket. And then you can deploy that. You can build a connected application, build a real-time application, build a recommender, lots of other really good sessions here at the ML Summit for you to learn about the different types of applications you can build with a trained model. And here we're going to talk about tuning it. But let's cover training a little bit more here. So what we want to know is that when you are training models on SageMaker, they are stored, they are searchable, they are versioned, and they are tracked by default. All of the artifacts, all of the metadata, all of your scripts, your hyperparameters, your performance results, your data sets, your images, again, all of those are stored as metadata for that job. So that makes experiment reproduction really easy, right? When you need to go look up how you produced a model from 6, 12, 18 months ago, if you trained it on SageMaker, you can just search for it, right? Just open up that SageMaker search bar that's in the SageMaker console, type in the S3 bucket that you used, and then you can get the training job right off the bat. You also see that all of those jobs are logged. So every time a training job is running in SageMaker, you can open up CloudWatch, another service at AWS, to view the logs on that job. That's going to give you the moment-by-moment insight into what's happening with your model. You can actually write print statements in your script, and then they'll show up in CloudWatch. So you can use that to debug, and again, really understand why our models are doing what they are. So you can use your own XGBoost script, right? So in this case, we're bringing our own XGBoost model. This is an Abalone model, and we're importing. So from SageMaker, we're importing this XGBoost object. So what's going on here? What's going on is that we are using a pre-built image that AWS is managing, right? AWS has a pre-built image of XGBoost, and we are importing that here, basically. We're referencing it via the SageMaker Python SDK, which is this Python package we're using. So we're referencing this pre-built container. Now, to customize that container and really make it do what you want it to do, first thing we're going to do is bring our script, right? We're going to bring a Python script or a whole directory, right? If you have hundreds of lines of code, you're going to point to what's called the source directory, and then you can get a whole repository of code that's just going to run on your SageMaker cluster, which makes retraining jobs a lot easier. But so we have our entry point set up. We also have a framework version, and so that is just what it sounds like. That is the version of open source XGBoost that we are using in this container. Now you're thinking, well, how do I use a different version, right? How do I use a version that's maybe not supported, or what do I do? So in that case, you're going to bring custom Python packages and custom system requirements into a requirements.txt file. So when you pass in that source directory argument, SageMaker by default will look for a requirements.txt file. We'll look for your Python packages and we'll try to install them. When you have a non-Python package install, what you can actually do is point to a bash script. So you can actually just define a bash script, use that as your entry point, we'll execute it, and then you can install really anything that you need on that instance. So we have our hyperparameters defined. We have an execution role, so an AWS concept to give this job the permission that we need to execute. And then what do you know? We've got a cluster config. So here we're running on 2 EC2 instances. So that's a distributed XGBoost job. That's the type of the instance we need. And that is the output of that job in S3. So when this job finishes running, when it completes, SageMaker is going to copy all of those artifacts, drop them back in S3 for us. Then again, that's where they're searched and they're searchable and they're versioned. So we're pointing to our inputs. So we have our train and our validation inputs, and those are objects in S3. Those are CSV files in this case that are just sitting in S3. Then we call estimator.fit. And new instances are coming online, right? We have 2 net new instances that are turning on. SageMaker is copying the XGBoost image onto that cluster. It's going to execute our script, and it's going to copy our data set from S3, right? So it's actually executing our job for us. Here is another view of training with our own deep learning model. So in this case, we're doing the same thing, except we're importing a PyTorch image. So we're importing and pointing to a pre-built PyTorch container. And so we're going to point to that PyTorch container, and we're bringing our entry points. We're going to bring our own mnist.py script. We'll bring that right there. Execution role, same as last time. Framework version. If you need a version of the framework that isn't natively supported out of the box, just drop down to a previous version, but then pip install whatever you need, right? In that requirements.txt, just bring in the cutting edge version that you really want to work with that has that one push that solves your problem. So put that in there. And again, you can define your instances right up here. So we have 2 instances. These are C4 XLs, et cetera, life goes on. Another thing you should know about training on SageMaker is that you can save up to 90% of your costs by using Spot instances. So Spot instances are a way that we can utilize what's called the Spot market on AWS. Spot market at AWS is essentially excess capacity. So Amazon has a lot of compute power, and a lot of compute instances. And as it turns out, not all of those instances are being fully utilized all of the time. There's some ebb and flow. And so when there's a dip in the usage, we expose those instances to customers in the form of Spot instances. Now, this comes with a couple caveats. Now, on the upside of a Spot instance, you get to save dramatically. And this fully includes P3 and P4 instances, right? So the most advanced hardware that you can use to train your model on is fully supported by Spot instances. So that's a pretty big saving margin right there. Now the downside is that you may have to wait for your job to execute. So that's why when we're running this in SageMaker, so first we're going to pass in a hyperparameter, right? We'll pass in that hyperparameter saying use Spot instances, set that guy to true. And then we're going to also specify what's called a max wait time. So your max wait time is just what it sounds like. It's the total amount of time in seconds that you are willing to wait for this job to execute. What I usually do is I take max runtime and I just multiply that by 3. So I'll just do max runtime by 3. Actually, in this case, that was not the case, but that's fine, right? You figure out what your own personal max wait time is. That's a personal choice. And then we also want to store our checkpoints in S3. This is especially the case and especially acute for deep learning models because there's a possibility that your job that's running on Spot may be interrupted. So if your job is interrupted, we want to make sure that we're sending those checkpoints to S3 in order to revert from that previous job. So definitely something that's good to know. So take a look at Spot instances on SageMaker, and also, of course, look at the SageMaker savings plan, and go ahead and make sure that you're saving as much as you can. And so now you're asking yourself, well, so I've gone through the work of packaging up my model in SageMaker. I ported it into this estimator, and I know that my training job works, but what's an easy way for me to get a good model once I've done this in SageMaker? And so the answer is what's called automatic model tuning. So there are 4 steps that we want to go through for tuning our own models on SageMaker. And so step 1 is what we already learned about doing, right? That's packaging up our Python scripts in a SageMaker estimator. So in this case, we're taking a PyTorch container and we're sending in our mnist.py script right here. We have these hyperparameters that we're going to supply as an argument. So we'll supply those hyperparameters. And then over here on the right-hand side of the screen, you can see the model definition. So we have some just generic model that we're defining. And then there's an if name equals main, right? So at the bottom of that script, there's a little executor. There's that little executable. So right inside of that executable, we want to parse the args. Arg parsing is a really helpful package in Python. We use it a lot in SageMaker, so you definitely want to get comfortable with that. But it's a way to basically send in these arguments. So we'll actually send in the hyperparameters, any other extra arguments you want to add. You can drop those into your estimator and then read them from your scripts. So we'll do that here. And then you just call train, right? So parse your args, train your model, and that's all you need to do. So that's packaging up your Python script in a SageMaker estimator. So once we have that Python script packaged up in a SageMaker estimator, the next step is to define that objective metric. So remember, we were looking at those different ways to evaluate machine learning models at the beginning, and we want to define those here. So right in that training script we're using to run our job on SageMaker, we're going to define what our objective metric is going to be. Is it the average loss? Is it the max loss? Is it the min? Is it the quantile loss? Is it some custom, function that you have? Really anything you want to build. All you need to do is make sure that the regex string is searchable. So in your training script, you actually want to put in a print statement is what you want to do. Whether you're printing this or using some logger, in that script, print out what your test loss is or your validation loss. Put in a print statement in that training script. And then in the job config, so in the configuration for the job, what we're going to ask you to do is supply a regex string. We have a lot of examples of regex strings. So what you'll probably do is just copy one of our examples and drop it in there. But you're going to use a regex string. So you're going to need to supply this regex string that's looking for this search pattern. Give this thing a name, write average test loss, the direction it's going in. So we're going to minimize the loss, and then we're going to put this into this object right here. And so Again, we really need to make sure that that regex string actually does match that emission from our training script. If there's not a match, it's not going to work. We're going to get an error. So make sure that that training script really is emitting what we're looking for with the regex string. So once we have those two set up, once our training script is really emitting that right objective metric and the regex string is finding it, then we're going to configure the overall tuning job. So the overall tuning job takes a couple arguments. So we saw these at the top before, right? So just some arguments about the objective metric. So what it's called, the direction we need to go in, the regex string. We're going to supply the hyperparameters. So that's basically a dictionary, right? That's a key value object in Python where we're going to define keys, so strings, which are the name of the hyperparameter, and then these types, and then these range objects. So you're going to import that as an object from the SageMaker Python SDK. So you'll import the continuous or the categorical parameter, and then you get to supply the ranges for your hyperparameters, right? So the continuous for a learning rate, categorical for a batch size, pretty reasonable. You have full customizability on this, right? You can bring whatever hyperparameters, types of hyperparameters that you want to bring, and we will execute your job for you. And then we're going to build this hyperparameter tuner object. So same flow as last time, we're going to import the hyperparameter tuner from the SageMaker Python SDK. And then you remember we built this estimator object. So we built this estimator object to run a single training job. In the case of automatic model tuning, we're going to take that estimator object and supply that as an argument to the hyperparameter tuner. So the hyperparameter tuner actually does two things for us. Number one is it orchestrates child training jobs. It orchestrates a number of training jobs, and those are defined by the estimator that we bring. Number two is the tuner is going to use Bayesian optimization to find the next best version of the model, and that's what we're going to look at in a second. So again, we're going to supply that estimator. Supply the objective metric name, hyperparameter ranges, metric definition. We also want to bring the maximum number of jobs in total and the number of jobs we want to run in parallel. So again, the tuner is operating like an orchestrator. And let's take a look at that here. So when you execute your job, when you hit go, we are going to run up to exactly the number of max jobs that you define. So maximum total number of jobs is exactly the maximum number of training jobs that we will configure, that we will run on your behalf. And so we will execute those jobs for you. What's going to happen is we'll do those in batches. So for a single point in time, we will do up to 3 jobs. Again, because we defined max three in parallel. So we're going to run those 3 jobs, execute the scripts, and then take the results and plug the results into a Bayesian optimizer. So the optimizer is going to execute jobs number 1, 2, and 3. Once those jobs complete, the results go into the Bayesian optimizer. The optimizer selects new hyperparameters, and then we start executing jobs numbers 4, 5, and 6, and on we go. And so if you're asking what is Bayesian optimization, so essentially you can read about this full robust paper. You know, we're running short on time, so we're gonna speed things up here. You can bring your own hyperparameters in SageMaker, fully supported, get those defined. As long as you can read that from the arg parser, you can bring that in as a hyperparameter. We have warm starting. So when you've done a hyperparameter job, you can reuse the settings, reuse the model to run a child tuning job that's going to be hopefully more intelligent. You can use transfer learning to enable more data, actually. So when you are working on a project where you're running a child job, or a parent job rather, and then you need to execute a second job, you can use transfer learning to add additional data sets. So that's fully supported. And so both that original paper is available on arXiv, and another paper that we published actually won an outstanding paper award last year on fairness. So tuning hyperparameters with an eye towards fairness. So that is another pretty cool project. So building retrain and retune pipelines. So essentially, we're going to start with some event, and that event, you have 150 different events on the cloud, whether that's an upload to S3 or a time of day or from a monitor. Your event is going to trigger a Lambda function. That Lambda function typically is going to point to an S3 bucket. You're going to want to point to SageMaker, and then SageMaker is going to grab your new data, and it's going to grab your model. So just make sure you pass in those job settings, pass in the script, pass in all the specs that you want to use, and SageMaker will execute automatic model tuning on your behalf using that image that you defined. And so rather than just retraining your model, you can actually retune that model to make sure that you're getting the best performance that you can. And I should mention that you can also enable early stopping. So when you are running automatic model tuning on SageMaker, make sure to add in an extra hyperparameter to enable automatic early stopping, which means that in the event that your job is not, the performance of your job is not getting better, say your AUC is not going up or your loss is not going down, make sure you enable early stopping, and then we will kill your job to save you costs. Lastly, you can also tune ensemble models. So based on bringing your own scripts and based on setting in your own hyperparameters, you can build, really whatever type of hyperparameter range object you want to build. Get that set up, define that as a script, and then use the Bayesian optimizer. And so with that, thank you very much. Feel free to look at the resources, lots of ways you can get started with machine learning at AWS Training and Certification. And we are out of time. So thank you very much, Emily Weber. Feel free to ping me on LinkedIn. You can interact with me on Medium. I'm pretty active on Towards Data Science. So feel free to follow me there and let me know your thoughts. And so with that, thank you very much.